Hello and welcome to the chemistry solver for the first semester. It's a program for your TI84 plus CE or TI84 plus CE Python calculator. So without further ado, let's get started. We're going to do all the dotted ones here on this worksheet student sent to me. So look, we're going to press the PRGM key. That's how to get to your programs. And then if you have this option, we're going to go to TI Basic. If you have just a regular TI84 plus CE, it's just going to go to Basic automatically. And this one's called Chem 1 V5, so Chemistry 1 Volume 5. It's constantly updated. You get free updates for life once you buy one. But let's work through this. So the first question, we can label. And look, it can't do everything here. I think it can do roughly half. That's reality. And look, just so you know, chemistry and physics kind of follow the same thing. At first, it's a lot of theory and facts and knowledge. The beginning of chemistry, it's like 80% that, 20% calculations. And then towards the end of a chemistry class, it's like 80% calculations, 20% knowledge-based stuff. So this program, and it's similar programs, Chemistry Solver 2 and the physics solvers, run much the same way. So look, without further ado, first thing, dinitrogen pentaoxide. So that's going to be at our references and data. And that's going to be prefixes, like the naming, just so you know it's a reference data naming. So we can choose option 4. And then it looks like, oh, dinitrogen. Okay, that's 2. So nitrogen, by the way, is N. So that's going to be 2. And then pentaoxide. Oh, cool, 5. So that means it's going to have a subscript. And by the way, subscript means that number at the bottom there, rather than a superscript at top, kind of like a exponent. But so it's N2O5 is the name. And that's what's cool about the program. It has a little reference data. And look, comment if you want to see more stuff on the TI84 calculator programs, such as this, like a student I've been working with since last year. She sent me this and I was like, okay, cool. I'm going to dolly up the program to make sure it works as well as it can for you. Okay, perform the following calculations. I'm going to zoom in a little bit so you guys can see a little better. 300 grams PbCO₃ to molecules. So look, first thing you need to do this is, I'm going to put 3A up here. We need to find what they call the molar mass or gram formula mass of PbCO₃. And look, for the unfamiliar, I want to walk you guys through this. What that means is we're going to have 1 of Mg. We're going to have 1 times the carbon. And this 3, sorry, it should be a little subscript here. The 3 means 3 times oxygen, so we'll go 3 times O. And you're like, okay, what the heck does this mean? So I'm going to go here, and I got Mg. So look, Mg, I'm not sure if you can see that. You're probably going to be equipped with a periodic table. This is late October, by the way, before Halloween. I hope to have a periodic table program for you guys so you guys can get all this info. But magnesium is 24, we're going to go 24.31. So that's going to be 1 times 24.31. That's its gram from the mass, by the way, which is going to be 24.31. Okay, man, sorry, I'm a little crowded here. I'll try to move everything. Oh my gosh, I'm going to move the G of the Mg. Okay, thank you for your patience. Flame me in the comments if you're upset, which I understand. Okay, so carbon, I'm pretty sure is 12. Looks like it's going to be 12.01. We'll put the 12.01. So 1 times 12.01 is 12.01. Okay. And then 3 times oxygen is going to be 3 times, and I already know it, it's 16. So, it rounds up to 16. 3 times 16 is 48. And again, if your periodic table has slightly different numbers, you're going to be okay. So let's go back. Actually, let's exit the program for a second. So let's say you didn't know how to do this. You know what? You could actually run it and do it like this. I'm going to show you something real quick. So what we're going to do is the stoichiometry. And then we want to go, we're starting from grams, by the way, G, and we're going to go to molecules. So we go to grams, moles, molecules, which is option 5 for the stoichiometry menu. So we're going to choose option 5. Okay. We want to go straight grams to molecules if we can. So option 6. So look, the grams given is that 300. That's the given number, the 300 grams. So we're just going to type in 300, and it's really fine. The molar mass, that is the royal pain in the butt where you need to use, for now, a periodic table. I'm working feverishly on a program to do that. but that might not be until like Thanksgiving time. So look, you could just put this in parentheses because you're like, instead of having to go to the regular home screen of the calculator, we just do 1 times 24.31 plus 1 times the molar mass of carbon, 12.01. And again, look, this is what's insane. I've had a student, I used to tutor students in chemistry. This is probably before you were born. And we'd all bring periodic tables, and their numbers and my numbers didn't jibe all the time. It was kind of weird. But that's just how life is. But look, it'll calculate all this. It'll calculate the molar mass here. It already did it. It didn't show us the molar mass, but you can do that by hand here. But the molecules is going to be 2.14. Now look, 2.14255. So you can see this E24. I'm going to write E24. And again, to the uninitiated, don't worry, it's cool. I'm here to decipher what all of this stuff means. That means 2.14, I'm going to round to 3, times 10 to the 24th. That's what that E24 means. That means times 10 to the 24th. So that's molecules of probably magnesium carbonate. Man, my naming isn't so good. It's been a long time. So that's the answer for 3A. Now, let us go to 3B. We want to go from molecules to grams. So that's option 5 here, molecules to grams. Now the molecules is 8.12 times 10. And by the way, this is the raised to the, it's called the caret symbol. I'm not even kidding. 10 to the 23rd. Okay, that's on molecules. What's the molar mass? Well, check this out. We just had the molar mass of carbon and hydrogen, right? So watch this. I'm putting parentheses again. It's 6, because of that subscript 6 here, 6 times the carbon. So 6 times 12.01 plus, okay, so that's the carbon taken care of. And then what's the subscript for the H? Yes, I heard it through the internet. That's a 6. Thank you for saying that out loud. 6 times, hydrogen's like, I think it's 1.01. Here I am thinking we've already had it. Yeah, I'm going to go 1.01. I'm going to round. Your book or thing might have a different answer, but I'm just going to go 1.01. Okay, so we're cool. Bam. 105.3 grams. So this is 105.3 grams. And I'm labeling units. Look, I'm more of a math guy than a science guy, if there's such a thing. But I'm not used to labeling units, so I'm used to losing points. Don't do that. Don't be the knucklehead I was when I was your age. But I'm just trying to give advice here to my younger self, I guess. But if you're already good about labeling units, just regard all my my advice here. Okay. I'm going to zoom in again so you guys can see totally what's going on here. What we want to do for this next thing, for number 4, I'm going to go back. And then stoichiometry, I want to know percent composition. That's percent comp. Oh my gosh, I probably should write that out. That might freak you out. Percent comp. We're solving for empirical formula. Oh my gosh, never mind. We got to go back. We want to go empirical formula, number 3. Okay. It's a 2-element. Look, I can only put 2 and 3 elements here. If you have 4 or 5, you're out of luck. Sorry about that. So we're going to go 2-element. Mass of A. Well, I think carbon, let's go back. Carbon was 12.01. Sorry. We're going to use these numbers. Sorry. My bad. I know I have cognitive decline. 92.24 mass of A. The atomic mass, that is the 12.01. Okay, so just so you know, we're going to assume when they give us percentages, so this is probably the most important thing you'll hear in this video. We have percentages for percent composition. We're going to call that their mass. And we're just going to assume the sample that they're giving us is 100 grams exactly. Okay, but the atomic mass, that's the thing from the periodic table, the 12.01. So then the mass of B, that's going to be our hydrogen in this case. We're going to write it or enter it as 7.757. And then what's the atomic mass? I think it was 1.01. I'm just going to roll the dice with that. Okay, so the element A subscript is 1. The element B subscript is 1. So empirical formula would be C₁H₆. Now, if you wrote that, most teachers would think you're a lunatic because we just don't put subscripts if they're 1. So we're just going to write that CH, okay? So just be cool with that. Now, we want to find the molecular formula. So I think we're going to go back. And then we want to go empirical to molecular. That's option 4 here. A subscript is 1 because that's a subscript of our A thing. This is kind of like our A and this is our B. And their B subscript is 1. C subscript 0 because this is assuming 3 possible elements. The molar mass, by the way, I'm like, oh, I don't want to calculate this in my brain. It's 12.01 because it's 1 of the carbon plus 1 of the hydrogen, so 1.01. I would have said, say if it was 5 of the hydrogen, I would have put 5 times 1.01. Okay, the target molar mass, we're going to say molecular weight, 78.12. Let's see if this is right. Okay, good. The multiplier is 6, so the A subscript is 6, B subscript is 6. So I think this is benzene. I'm not sure. Look, flame me in the comments. I'm definitely not a chem guy, and I make no pretensions. I'm just trying to help people out with chem here. C₆H₆ would be the molecular formula, and that's how you do those. It's a super handy program. And look, this program did not have this functionality 4 days ago. I spent 4 days coding this. Complete pain in the ass. As I get older, I have less and less hate in my heart. And I don't hate anybody nowadays enough to wish them to be coders of any kind, calculators or computers. Man, dude. Dude. Okay, using the solubility table, predict if the aqueous solutions will form a precipitate. That means something comes out of solution. If it's in solution, think it's like still mixed. Like, give an example, like water, they call the universal solvent. If it's still there, like you wouldn't see it pop out. Precipitate means it comes out. Like the best example I can give you, if you're young, you probably mix milk with like chocolate milk syrup. And if it's just a good mix, you're like, hey, cool, it looks like chocolate milk. But if you do like me, I'm like, man, I just keep dumping that stuff in, like the liquid syrup. Dude, it came out hard on the bottom, like solid chocolate. So you call that a precipitate when it comes out the bottom as a solid. Okay, so we're going to go, I think, to reference data and solubility lookup because and then look, cation, I probably should label this. This thing's positive, anion's negative. So we're going to try to look it up by cation. Okay, we got a Zn 2+, hopefully some more. Oh my gosh, thank you. Okay, so Zn. Generally soluble with most anions. Zinc with sulfur, it looks like, is insoluble. But that's sulfate, so that's soluble. So, no, so it's soluble. So I'm just going to write soluble just to be safe. We're going to go back. Let's see, lead. Oh, by the way, we'll just look up lead right here, number 4. Okay. Pb2+ compounds with Cl negative, Br negative, I negative, insoluble, SO4 2 insoluble. I'm not really sure about that one. I want to go back. I want to look up by anion because that's like it's not really declared well. We want to go more anions, man. Please be here. CO3 2 negative. Okay, good. What's the deal here? Insoluble except with ammonium. Okay, NH4+. So we're going to say insoluble. So it's going to make a precipitate. So look, I'm going to write this. Okay, we got this PbCO₃, but watch. This is what happens. This superscript shoots down here. So technically that would be a 2. Now this superscript, the 2 negative, shoots down here. But look, if we have equality here, they cancel each other. It's kind of weird. So it's just going to be PbCO₃. That is your thing, PbCO₃. So we're going to leave that as is. Okay, just so you know, we're doing a little stuff outside the calculator to get this done. Going to go back. Okay, cation. Let's try it by cation. Man, tell me we got aluminum. Good. Al3 plus. Okay. AlOH3 is insoluble. Oh, good. It's insoluble. What does insoluble mean? Forms precipitate. So we're going to write, oh my gosh. And the calculator program wrote it down for me. Because you see, look, it follows that same deal, right? It's Al3, OH, like 1, 3 positive, 1 negative. So look, this is what happens, right? We shoot this down. This becomes a 3. You got to enclose this in parentheses, by the way, if it's more than one element. So technically it's Al1, OH3. Again, your teacher's going to laugh at you if you write a subscript of 1. So it's going to become this like charcoal gray thing, AlOH3. That's how we get that. Let's go on. Oh, Cu2, copper 2. Let's check it out. CuOH insoluble. Cu3PO4 insoluble. Oh my gosh, even has the answer for us. You know what? This program's awesome. And not just because, I'm selling it, but dude, I want to go back in time with this Terminator style, like 84. That's a little before when I was taking chemistry. I hand this to my younger self as a teenager. Like, follow this program if you want to live. Okay. That's my bad. I don't know. Okay, imitation. Pb2. Let's see what's going to happen here. So Pb2 plus compounds, insoluble. So we are going to have precipitate. So it's PbBr. Now look, we're going to follow those rules, right? You're like, what rules? This 2 shoots down here. This is a 1 if we don't have it, which is it's a 1. It's a 1. So technically it's Pb1Br2. But look, again, your teacher's going to think you're wacky if you put 1 as a subscript. So it's going to be PbBr2. Okay. Last question, I believe that the calculator can handle. And look, if you have this program, it's either in the chemistry solver bundle, which is a great deal. It's only like $10 more than the current program. Oh, and by the way, there's always discount codes on the site or through YouTube videos. If you look hard enough, you'll save like 10, 20, 30% of the programs. I'm not kidding. Just look on the site too. You'll see it at the top as a banner. You just got to join the email list. But if you don't, even if you don't like that, there's a YouTube video recently about Christmas. It was like supposed to be Christmas in July video. It came up to be Christmas like in September or August, whatever. Has a discount code for you. So look, enough of that. We're going to go to pH, POH. I'm going to go back. Acids and bases. That's where you calculate POH and POH. Percentage hydronium ions. That's what it stands for. So look, we're going to calculate pH. What is hydronium ion concentration? That's what that H plus means in this little I think it's like a bracket here. We write 4.23 times 10 raised to the what? It's a -6. Now look. I would get rich if every time a student emails me like, hey man, your program doesn't work, I put the negative. Dude, you probably put the wrong negative. This is the minus. This is the negative below the 3. I'm going to keep saying it because somebody's going to write in the comments, hey dude, your thing doesn't do negatives well. Guess what? It does negatives excellently. You need to learn how to do negatives. It's this negative symbol here. Now I got to delete them. I shouldn't be losing my cool, but I am. Okay, watch. Boom. I just changed this program to give us pH and POH just because of this question by A star. A star, props to you, woman. Good job. So look, pH is 5.374. I don't even know what the significant digits are or the rules for that. But I'm just going to round to 4 digits. It's probably going to be 3 digits. So, you can make fun of me and say, hey, you're a math person, not a chem person. Ha, 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 ha. I don't care. I'm not offended. My dad was a chem guy. He's a chemical engineer. He got accepted at MIT, but didn't go. Thought it'd be working like working at a sweatshop. Back in the day, back in the late 50s, early 60s. Okay. Look, hope all is going well. Comment. I like if you like, subscribe. I do give discounts to programs all the time. And I do improve them. Like I said, everybody who gets these, who buys any program gets an update, free updates for life. And then I am including a periodic table program that's going to be not as cool, but more informative than the app you already have in your calculator. So look, let me just show you this. You can just, you know, say goodbye right now if you want, but let me show you something. On your apps, they have a periodic table. I'm not even kidding. Look at this. Boom. Hydrogen. Let's find out stuff about hydrogen. Look at this, man. It's got the weight, neutrons, protons. Okay, you know what? My thing's not going to be as cool as this because I don't know how to code this cool green and everything. But you can find the weight of all this stuff. And now watch. See, these keys refer to these keys up here. It's kind of weird. It's like function keys on a keyboard for a computer. And you're like, hey man, I want to go find carbon. Let's find out a carbon, right? You're like, oh, okay, 12.01, like I said. And it's got the weight. That's typically what you want for all that stuff we're doing before. Let me just show you, just so you don't think I'm a loon. To do all this, to find the gram formula mass of these things, you could just tap into this periodic table. And guess what? I made a video of this when you were a wee child. I made a video of this, I think, in probably like 2011. I'm not even kidding. It's like one of my biggest videos, even though I'm a micro YouTuber. Okay, look, peace. Good luck. It's available at mcstutoring.com. If you have questions or anything you want to add to it, contact me on the site. I'm totally cool. If you're civil, I will respond. And I do respond to all civil comments on my YouTube channel. Just give me some time. There's a backlog. But look, take care. Good luck on all your chem stuff. And see you next time.